Hello and welcome to day 8 of learning ML from chatgpt. So let's get started. I had a quick look and we're learning about loss functions and optimizers. So please give me day 8 lesson. This time, please only give me the code for TensorFlow. Okay, let's get started. So backpropagation, loss, and optimizers. Implementing backpropagation in TensorFlow and PyTorch. Backpropagation, a method used to calculate the gradient of the loss function with respect to the weights in a neural network. It helps in adjusting the weights to minimize the loss function. Okay. A function that measures how well the model's predictions match the actual data. Common loss functions include mean squared error for regression and binary cross entropy for binary classification. Optimizers, algorithms used to update the weights of the neural network to minimize the loss function. Common optimizers include SGD, stochastic gradient descent, and ADAM. Good example, training a neural network in TensorFlow. Below is an example of training a simple neural network using TensorFlow. So this is what we saw yesterday. Okay. And we just, the extra thing here is just plotting it with matplotlib. And here we're getting random data like we did at the start. We're going to see the accuracy of the model. So data preparation. We create a simple dataset with 2 features and a binary label. Okay, the model consists of one hidden layer with 8 neurons using the ReLU activation function. Okay, so this is the hidden layer. This is not the input layer. Okay. Upper layer 1 neuron using sigmoid activation function. So sigmoid is on the range of 0 to 1. And it's used for binary classification. Compiling the model. We use the ADAM optimizer and binary cross entropy loss function, which is suitable for binary classification. Training the model. We train a model for 50 epochs using a batch size of 32 and setting aside 20% of the training data for validation. The history object stores the loss and accuracy metrics for each epoch. Plotting the learning process. We plot the training and validation loss over epochs to observe how the model learns. This can help in detecting issues like overfitting or underfitting. Similarly, we can plot the training and validation accuracy to see how well the model is performing on the training and validation data. Evaluation. Finally, we evaluate the model on a separate test set to see how well it generalizes to unseen data. Assignment. Okay, this is a pretty short lesson. Implement the code above and observe the training process. Try changing the number of neurons, layers, or activation functions and see how it affects the model's performance. Okay, quite a short lesson today actually, and we've covered most of the things that we've seen today. Just look ahead. So this is week 2, but I hadn't been uploading one of these videos every day, so it's a bit off schedule. But okay. Then deep learning architectures. Okay. Deep neural networks, hidden layers, nonlinearity tomorrow. Overfitting, underfitting. What? I swear we just did this. Huh? How have we done this one already? We've already done day 10, L1 and L2 regularization. But it hasn't been here. Okay, and we haven't on day 6. I reckon. I think we did this in day 6, but I can't remember. Why didn't we go pass in the wrong one or something? I don't know. We can always go back to it tomorrow, as we've already done that. So copy the code and just says changing neurons, layers, or activation functions. See how it affects the model's performance. So we saw yesterday it was pretty much getting 100% accuracy when we changed the neurons to 1024. I'm going to need to just change my screen a minute. And just sign in. Don't know why it signed me out. It's a bit random. But okay. Okay, I think we're signed in now. Here we go. So I'm just going to paste this in here and have a look at it and the accuracy.